Properties. Testing. Now it's good. Okay. So here's how you don't waste time. Start copying things while I'm lecturing. So what do you have to copy? Go to brianteaches.com. Go to chemistry. Open up the cesium page. Cesium. Now, go to your site. Go to sites.google.com. I will open up one of mine for period 4. Sure. First, we got to make a new page. To make a new page, you go to Pages. New page. Let's name this cesium. We've made a new page. In order to find that page on the home page, you got to make a new button for cesium. So I want you to duplicate the silicon button and instead put in cesium. C-E-S-I-U-M. And then you're going to insert the link for your new cesium page. And just like all the other chemicals that we do, I want you to select an image, and search for something that looks like cesium. I'm just going to find some cesium. I like this. I'll use this. And now we're ready to go for our cesium page. So I will be doing the lecture on all this material. It would be wise if you open up yours at the same time as you open up mine and copy the information over. So if you go to insert, I see that this is 3 blocks with 2 pictures. So I would insert this 3 block template, and I'm just going to copy and click and paste. Copy and click and paste. Copy all of this information. All of those things that you have as a question, if you rewatch the video, it will be right there. I'm making the video right now, so hopefully it's smooth and you can use this as reference, okay? And then I can help you guys more when we do a catch-up day next week. Next week will be a good catch-up day. But this week I'm going to be going through this, and I want to make sure I hit all the content. So start copying everything here. So let's talk about cesium. Cesium. Cesium, this is what cesium looks like. And cesium on the periodic table of the elements has an interesting pattern, which is that it has 2 different names. On some periodic tables, it's CES, and on other periodic tables, it's CAES. What the heck? Well, why? Well, because some elements have different names in different languages, and some elements even have different spellings in English. Cesium is one of those. So in British English and the IUPAC standard, and IUPAC is the International Union of Pure and Applied Chemistry. According to those, it is CAES. But in the United States, it's just regular old cesium without the A. It's just CESIUM. So the battle between the UK and the US wages on between this spelling. Just like the Revolutionary War. Who's right? Who has the correct spelling here? Well, I just ranted about Wikipedia, and this is sort of one of the reasons. Wikipedia has a ton of information, and it also has lots and lots of dialogue behind that information. There are pages dedicated towards the conversations that go along the edit. So here's a page on Wikipedia. This is a discussion about which spelling should be used. And this argument has been going on since 2004. And this person said the argument is futile. The best and most obvious solution is to leave the page where it is and change every occurrence of cesium to the more correct CAES. Google results are inadequate. Everyone knows American English is more popular, while international English is more correct in being universal. It's really too bad that Americans have skewed such a wonderful language. This person is throwing mad shade towards Americans. But there's a huge discussion about this, about which one should we use. Wikipedia is very comprehensive. So we have to figure out, well, who's right? Who's right here? Well, if I looked at different languages have different spellings of cesium. But what spelling is more popular? Is it the ES or the AES? Almost all these other languages seem to be ES. Cesio, Cesio. It's all the CES version. But one thing you might notice from here is that even if the language is different, they're all relatively similar. They all seem to be pretty similar. No matter what language it's in, it seems to be very, very similar. Words like that have a similar pattern in multiple languages are actually known as cognates. And cognates are really popular in science. Very popular in science. So here's one set of cognates in Spanish and English. Hopefully you guys are copying all of this over while you're listening. If you're not, you are wasting your time because you will have to do this eventually. And I will say the majority of people that fail the class fail it because they weren't doing the website. Because this is probably the most amount of work that you're going to be putting into the class. And if you don't do it, then, a lot of students will tell you that have taken my class in the past, if you don't do the site, you may end up failing. And I don't want anybody to fail, so I hope everybody's staying on top of it. Anyways, these cognates have a very similar word in both Spanish and English. All of these science cognates are very similar. Cognates are words that by definition have the same linguistic derivation as another from the same root word. So those are cognates, and we're gonna do a little activity on cognates. So, speaking of naming, I did mention that IUPAC, which is the International Union of Pure and Applied Chemistry, they have naming standards for naming all molecules that we discover. And their strict naming standards help us all be on the same page. So we're all on the same page. So IUPAC is responsible for most of the naming, but different industries use different naming systems. Like in the cosmetic industry, they use the INCI system. The FDA uses a different system to list ingredients, but most of them use IUPAC. So nomenclature is the study of words and naming. And the nomenclature for chemicals is a huge part of organic chemistry. Organic chemistry is a class that a lot of people complain about being very difficult. And a lot of it is just making sure that you know the names and understand the patterns. And there are a lot of patterns with the namings of these various chemicals. One of them is the naming schematic for the number of carbons that you have in a hydrocarbon compound. Like, when I say the word meth, what does everybody think of first? A lot of you think, well, did somebody just say cocaine when I said meth? That is not even the same type of drug. A lot of people, when somebody says meth, they think, drugs, meth. No. Just so you understand, it's called methamphetamine. Amphetamines are a class of drug that cause you to have a specific bodily reaction. Most people, if anybody has ADD, sometimes they used to prescribe Ritalin for ADD. That's an amphetamine. The meth just means that it has a methyl group attached to it as a one carbon group. So meth doesn't mean drugs. Meth just means one. Eth is 2, prop is 3, bute is 4, and then after that it actually just adheres to geometry like pentane, hexane, heptane, octane, nonane, decane. So hex, hept, oct, non, dec. That's from geometry. You guys should know those ones. You just started? Well, good. You guys will get to that. So pent means 5, hex means 6, hept means 7, oct means 8. So on and so forth. You can change these molecules to different functional groups and they do have very different reactions in your body, or just different reactions in general. There is, shh. Remember, guys, I'm trying to record the video for this so that everybody can hear this. Everybody can watch this video and make sure they get through the website quick. Um, not every cognate works out well in every language. Here's one that's kind of ironic for us, for English. Almost everywhere else in every other language, this tropical fruit right here, what do we call this? There's a pineapple. Only in English. In Arabic, it's ananas. In Armenian, it's ananas. In Danish, it's ananas. In Dutch, it's ananas. In Spanish, it's ananaso, and it's ananas, 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 ananas. It's ananas. It's ananas in Spanish. No, it's ananas. You might be using a more slang version of it, but it's ananas. It's ananas in every other country. So there are some deviations from the rule. Anyways, we're not just fighting over the spelling of cesium, we're also fighting over the acquisition of cesium. Have you guys been following the information that's coming out of Afghanistan? Does anybody know what's going on in Afghanistan? Okay, Afghanistan, we retreated. Our military has pulled out completely, so a theocracy has come in. A religious group has come in, taken control of the country, and says we are now the government here. That's the Taliban. Well, do you know who the new best friends to the Taliban are? Who's going to invest a lot of money into the Taliban? China. China is going to be investing a ton of money in the Taliban. Why? Why? Why does China want to invest money into the Taliban? Nah. Do you know why? Because Afghanistan has $1 trillion in lithium, amongst other rare earth metals. It all comes down to dollars. Every war that we've ever been in, it's all about resources. If we can't get the resources, then we usually take off. China thinks that they can have access to this lithium if they're buddy-buddy with the Taliban. That's a risky bet. Maybe it'll pay off. Who knows? But these rare earth metals are important for a lot of electronics, a lot of things that we do, and cesium is one of those rare earth elements. Cesium is super expensive. It's $83 a gram compared to gold. Pure gold is $55 a gram. It's really expensive. The other reason why cesium is expensive might be because America has absolutely no naturally occurring cesium. We get all of our cesium from China. We're at their mercy. Anyways, what the heck is cesium as a chemical? What kind of reactions does it have? Let's look at this guy.
Hello everyone. Today I will tell you about the most active and unusual metal on Earth, cesium. Cesium is an active alkali metal, which is located near the bottom of the periodic table of chemical elements. Only francium can be more active than cesium, but that metal is radioactive, and only an insignificant amount of it was obtained in its pure form to do any experiments with it. Because of its high activity, metallic cesium is being stored in special ampoules under inert atmosphere of either argon or hydrogen. Appearance-wise, cesium has a yellowish tint, like gold, but the price for cesium is still higher than gold. Due to the extremely small sales market and its highest activity, price of cesium can reach over 100 euros per gram. The vial, which you see on the screen, is 50 grams of cesium. Just imagine its cost. Cesium is unusual in that it has a very low melting point, only 29 degrees Celsius. If you take the vial of cesium in hand, you can see how quickly the metal begins to melt. Even while cesium is still in the vial, we can already conduct experiments with it. If you leave the liquid cesium in a vial for some time, it partially hardens, forming very beautiful crystals of pure cesium.
Alright, so this guy was trying to pull
This
cesium
means
out of a vial. Cesium reacts with air like super fast. It'll just explode. So that way it has to be stored in kerosene. He was trying to get it into this kerosene beaker, but he let some of it touch the air first and it just exploded. Yeah, cesium is super reactive. You want to buy it? It's $88 a gram. A gram of this, it's dense, so it'd probably be nothing. That little vial that he has was 50 grams. Yeah, basically, yeah. 4,400 bucks is what it would be if it was $88 a gram for 50 grams. Yeah, that's a lot. I mean, that's a lot. He might make the money off it.
oxygen in kerosene. You have decided to destroy the vials with a
So it was super gold, but then it became silver because it oxidized. It reacted with
liquid
oxygen.
cesium, but throwing it onto the wet wall.
He threw that empty vial, just the empty vial with a small amount of that cesium. Very explosive. So it's very, 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 very reactive. Cesium is very, very reactive. That's one reason why it's kind of expensive because it reacts with a lot of stuff. If you burn cesium, it has this color flame. It has this beautiful purple flame. Okay, but why is cesium important for us in society? What is the practical application of cesium? Well, this has to do with your quick write. And I asked for this one, for this quick write, if you had to define a second to somebody who didn't know what a second was, how would you define it? How would you define a day? What's a day? Somebody said, hey, what's a day? 24 hours. What's an hour? 60 minutes. What's a minute? What's a second? You just went back. You can't go back. You can't use circular reasoning. 1,000 milliseconds. Well, what is a second? Because I can go back to that one. At some point in time, you have to define what a second is. It has to be something. It has to be relative to something else. The same thing for any defined standard, like a gram. What is a gram? How do we come up with the concept? Yeah, it's a mass. It's a measure of mass. But how do we come up with a gram? What is a meter? Where do we get that? What is a degree Celsius? Where do we get all of these standards? These standards are they're based off something. They have to be based off something. So, a second. I'm sure so a lot of people are saying different things about other units of time. A second, way back in the day, we used to use a second. We used to base it off of a period of time that we are very familiar with. What's a period of time that we know for certain has a certain length of time? The clock. Yeah, but the clock is based off of our orbit around the sun, right? Our year. What is a year? How many days are in a year? Nah, 365.25. You guys are close though. A year is 365.25 days. Why? Because this is what it is. It's 365.25. Every single year is 365.25. So if our calendar is 365 days, we've lost a quarter of a day, right? So after 4 years, what's 4 times a fourth? Isn't that one extra day? So what do we do after 4 years? We have a leap year. We add an extra year because we have to account for that extra 0.25 every year. That's what leap year is. That's what the leap year is. That's why we have February 29th. So we can account for the fact that we've cut off that 0.25 day every year. Anyways, if it takes us 365.25 to go around, I shouldn't be jumping out of the camera frame when I do that. Then you could say, okay, well, 365.25 days, and then you could say a day is 24 hours, and so on and so forth, till you get to about 31 million seconds in a year. So that's how we used to base our time scale, is off of the orbit of the sun. And we have plenty of documentation of that all across our planet with sundials, etc. But there is a problem. There is a problem for when you set your time relative to astral bodies. Here's one of these problems. Do you guys know who Neil deGrasse Tyson is? Neil deGrasse Tyson. Yeah, he's an astrophysicist, a scientist. He's pretty popular. This is a Key and Peele skit that is kind of making fun of it, but it's still relevant. Parents tell you to do something, get it done tomorrow. You say, well, what if I get it done in 5 years? Because really, what is time? If we think about it in the scale of the universe, we've only been here. That was actually a real fact. If you compare the scale, the lifetime of the universe, the observable universe that we've been able to calculate through different lights that we've seen, then human history, all of human history can be compacted in the year of the universe into the final second. We've been here as humans for a second. With our individual lifetimes, we're here for about 100 years. It's almost non-existent. It's so irrelevant to the universe. Time like that, if we measure time like that. What's up, Jace?
She said that if she can go to rescue.
You don't have to ask. You can just go. He said to fill out the hall pass. If we measure time like that, it's not really accurate for our scale, our lifetime scale. So it's better to have something that's more accurate. So how do we define a second nowadays? It's actually not based off of solar bodies. Instead, we base a second now off of some very specific chemistry involving cesium. It's kind of complicated, so I'm going to let this guy explain it because he looks like a better scientist than me. When you look at that hair, I mean, that's a scientist's hair.
Cesium has quite a surprising use. It's used to measure time. I don't know if you've ever thought about it, but you could define 1 second as a fraction of a day. 1/60th of a minute, which is a 60th of an hour, which is then a 24th of a day. But the trouble with that is that you'd never be able to tell whether the Earth was going slower or speeding up, because the length of the day would change and you wouldn't notice it. So scientists have to have an independent way of defining the second. And this is where cesium comes in.
And so now here the cesium is going in as well. Right. So I'll shut the port door.
So the way that physicists define the second is in terms of microwaves and the frequency of the microwaves. We need a standard, something that can define a radio wave very, very precisely. And this is where cesium comes in.
So what I need to do now is open up this door here.
The point about cesium is that it's a big atom. It can absorb microwaves. The absorption of the microwave causes an electron to move from one energy level to another. And the advantage of cesium over all other materials is that this frequency is enormously precise.
It's pretty cool. It's really good. It's kind of.
So they can tune an atomic clock. They can tune it to a specific frequency, and cesium will only absorb that specific frequency or give it off. And then they can figure out, well, based off of that frequency, this amount of wavelengths will come out, and we're all going to call that a second. So across the world, they've built atomic clocks to accurately define the second based off of this atomic activity that is always consistent. So this was one of the first atomic clocks. They're still making atomic clocks, and they're making atomic clocks all around the world. I think these are some guys in India, so that everybody can make an accurate definition of what a second is, and we're all on the same page. Everyone knows what a second is, and it's all the same across the world. So that's what cesium is used for, and that's why one reason why it's kind of valuable. Anyways, you guys are supposed to copy all of this material on the white background, and then we have to make our original content. So I'm going to quickly go over the original content. It has to do with the words, the cognates that I discussed, and some things with time. So the first one, the Cognates Chart. I want you to make a copy of this cognate chart. So open up on my page, this sheet, File, make a copy. Make a copy of this. We'll call this cesium. I'll say Brian period 4. And now I have this copy. So this this spreadsheet is actually something that I borrowed from a professor at Northridge, but this cognate chart has Google Translate formulas in each of these. Right here it says equals Google Translate, take the word in A2 and take it from English into Spanish. So accelerate has a lot of words in different languages that all kind of seem like accelerate. They all kind of look the same. So that's a cognate. So what you guys need to do is you need to make 5 new words in this chart. After you've copied it, you have to make 5 new columns. So I'm going to select these first 5 columns by holding shift. You're supposed to make a copy of this chart. This is your chart when you have a copy. We have to add 5 new rows. So I'm going to select these 5 rows, insert 5 above. Now I want to copy these formulas. These formulas will automatically populate with the translation if you copy them over. So I'm going to take this formula right here, this row of formulas, and I'm going to copy it. So I'm going to select all of them, and I'll copy. So I've copied all of those. I now want to paste those formulas down this column. So I'm going to select all of these. And now I have all of these rows selected. I'm going to paste it, and it's going to automatically paste in the appropriate formulas. Now, this is referencing A7. This one is referencing A2. This one is now referencing A3. That's a nice thing about formulas. They will automatically change their references. So let's try a word. Let's try water. It'll automatically populate all the translations. So water is not really a great cognate because it looks like agua, aqua, agua. There's a lot of different words for water. Some people ask, wait, if it's not aqua, where did we get the word for water? I'd be willing to bet where we got the word for water is probably from the Germanic root, which is Wasser. So that's a little bit closer. But you could have another word like calculator. You're not supposed to edit mine. You're supposed to make a copy. File, make a copy. Then change the name so that it has your own name. It's yours now. Now, you're supposed to share this. In order to get your points, you must share it. You must share it. If I don't see it, then I can't give you your points. So change it so that anyone with the link can view. Now it's done. Now you could have copied the link, and now you're going to, well, actually, you don't even need to copy the link. If you just go to your website, where did I put mine? You just add. You're supposed to add to it. How do you add these? You just have to follow the instructions that I just gave you, but because we're cutting close on time, I'm going to continue on with the tutorial, and you can watch the video. Because the video, I'm recording the video right now, you can just pause at the spots that you need to. Anyways, insert your sheet, and you can insert the sheet that you just made, that Cognates sheet. And that will be your first few points for this page after you've copied that. Okay, so that's how you get that original content. Let's do the other original content. The other original content has to do with speed. Measure the speed of your typing. There's some people who think that they're fast typers. There's some people who think they're slow typers. I don't care how fast or slow you type, but I do want you to improve. Improvement is the name of the game at school. So go to typeracer.com. When you go to typeracer.com, you can enter a typing race. Let me test right now. I'm going to do one. I'm not really that fast on my work PC keyboard, but let's try. That was actually a very, very slow passage because that was a hard one for me. The last few I have done have been a little bit faster. Anyways, you must take evidence of that. So I got 72 words per minute. I think the last period I had 90. The one before that was like 92. Words per minute. Some people, if you're a professional typer, they want you around 60 to 90. If you're really good, there are people that can go up to like 150, 200. It is possible. They're just super, super fast. A lot of people will tell me, a lot of students think that they can type quickly on their phones. I have not found one single person that can type faster than 40 words per minute on their phone. If you can beat 40 words per minute on your phone because people think that they can type quickly, sure, show me the evidence. Because until I see the evidence, I don't believe it. I think that you are faster on a keyboard if you're trained for a keyboard. I wasn't actually trained on typing. I never took any class or anything like that. I just played a lot of computer games, and that just got me faster. You need to take evidence of this. In order to take evidence, use some sort of snipping tool. Like, oh, here was my 90 word per minute one just last period. So take a snip. You guys know how to take a screenshot now from the other website pages. Save that. I'm going to save this as typing 4. And you can go ahead and insert that into your page, and that will give you the additional content. So if I did this and I insert, so this is our other page, insert, images, upload, typing, and that will give you evidence for your typing. Okay? That is those. Those are the first two parts. The next part that has to do with time, because cesium is our time element, is a longitudinal study. A longitudinal study is one that takes place over a long time. So a longitudinal study, you have to have some amount of time that occurs. So I want you to make a copy of my longitudinal study of typing. File, make a copy for yourself, and you are going to add in your evidence for the typing over the course of at least 5 days. This is a longitudinal study, so you don't do it all in one day. You do one type racer one day, then do another one the next day, and then so on and so forth to see if there's any progress. A longitudinal study, you got to have some time involved. So I want you to document this over a course of time. In order to get full points on this, you have to do it at least 5 different days. If you do that, and then you embed this chart, then you'll get the 6 points right here. So if I did this, insert, and I put in my sheet, and I put in the one that I just made, which is the longitudinal study, and you're going to make a copy and make your own. You're going to be putting in your own information. You're going to put in the evidence. The evidence you should submit as a picture. It would be actually helpful if you had your evidence linked as a Google picture, but I'll go over that at a future time. So that's that. So you need to have, in order to get all of the points on this, you've got to copy the content. That's the 5 points from copying all of this. Then you got to make your cognate chart. You got to do the type racer, and you have to do a longitudinal study using your type racer information. The last thing that I'll have to say is that there is an extra credit opportunity here for designing your own longitudinal study. There are tons of different longitudinal studies that you could do. You could maybe graph how many views a certain music video has over time. You can check the growth of a plant over time. Longitudinal just means that it has to have some amount of time involved. Here is one that I did a long time ago, or not too long ago. I don't really ever shave. I never shave my beard. I just trim it. So I have this beard, right? Well, I actually do shave it basically once a year. I shaved it last time for, if we can get this to load, I shaved it for Dia de los Muertos. So I shaved my face so that I could get the makeup on here, and I took a 3D picture of myself so I could watch you guys. But I also plotted out every day with a date. I plotted out all of my different days for the beard growth so that I could track how quickly the beard grew. That is a longitudinal study that maybe you could participate in, you could do, but that's how long it took me. If somebody asks, how long does it take you to grow out your facial hair? Well, I'll tell you that it took me a month to get back up to basically my normal length. So that would be extra credit if you're interested in pursuing that. That's the cesium page. Good luck.